So all of you can see the lab manual there, isn't it? Yes. So can you all see that the first experiment is the verification of KVL and KCL for DC circuits. So all of you have done that observation, that Ohm's law thing. All of you have done.
Yes.
Verification of Ohm's law is done by all of you students.
Yes, ma'am.
Yes, ma'am.
Yes. So I kindly ask one of your the CR to create a Google Drive and drop everything in one Google Drive so that we can see whenever we want.
Yes, ma'am.
Yes. Okay. Okay. The first experiment is verification of KVL and KCL for DC circuits. And can anyone tell what is KVL and what is KCL? How do we do it? Ayush Ranjan? Ayush Ranjan is there? Hello?
Yes, ma'am.
Yeah.
Hello.
Can you
Am I
give the
audible?
statement? Yes. Can you give the statement for KCL?
Ma'am, it's Kirchhoff's current law,
Hmm?
and
How do you state the law?
mm,
Hmm?
Ma'am, the algebraic sum of all the currents.
Algebraic sum of all currents. That's all.
Equal to 0. Basically, the number of incoming currents is equal to number of outgoing
Number
currents.
of outgoing currents.
So that can be also stated as the algebraic sum of currents entering a node is 0. Correct?
Yeah, ma'am.
Yes. Right. So how do you define KVL? ANSH 31737. Who is that? Ansh is there? Ansh, you have to be interactive, okay? Yes. Ansh is active or inactive, is gone somewhere. Ansh, hello. Ansh, you're there? No, you cannot just log in and leave it like this, okay? Shashank, yes, is there? Shashank, yes. Shashank, yes, is there? Hello? No, he's also not there. Tejas, Tejasomi Seti is there? Hello, you guys are hearing me?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
yes,
Yeah,
ma'am.
Tejasomi Seti is there?
Yes, ma'am.
Is that person active? Yeah. Can you state the
Yes,
KVL?
ma'am.
What is KVL?
Come again, ma'am. I can't hear you, please.
KVL. Can you state what is KVL?
KVL. Okay, ma'am.
Yeah.
The algebraic sum of EMS applied is it. Ma'am, ma'am, can you hear me?
Yeah, tell me.
Okay. Ma'am, in a briefly, if I say in any closed loop, the total voltage around the loop is equal to the sum of all the voltage drop within the loop.
Yeah, so what we can say, the algebraic sum of voltage drop across each element in a circuit is 0.
Zero.
Correct?
Oh, yes, ma'am. Yes, ma'am. Yeah.
Yeah, okay. With this understanding, we'll be moving on to the problem of solving KCL and KVL to a particular electric circuit. Is it fine?
Yes, ma'am.
Yes, ma'am.
Yes, thank you. So, can you all see? Okay, I have not displayed it. Okay. Okay. So your lab session will be dealing with the first is KVL and KCL for DC circuits. Okay. So what is the aim and objective of this session is we will be computing the voltage and current of each circuit element. Okay, and then we'll be verifying the Kirchhoff voltage law and the Kirchhoff current law. Is that fine?
Yes, ma'am.
Yes, ma'am.
So
Yes,
the
ma'am.
components for the regulating the voltage to adjust the voltage to a particular value. Okay, so here the applied voltage is 10 volt.
Yes, ma'am.
So what we do is we do not get directly the 10 volt to connect. So we need a regulated power supply so that we can adjust the voltage to the value of 10 volt. Understood? So how many resistors we need here? Can you see in this experimental setup? We need R1, R2, R3, R4, R5. So there are 5 resistors and each resistor is having its own value. Got it?
Yes, ma'am.
Okay. The resistor, how do we get to know the resistance value from a given resistor? So there is a band 1, 2, 3. I think you'd have seen that resistor thing. Okay. So what I request you is go to some online and check out how do you find the value of a given resistor. Okay. Given, you should know, understand that Great Britain had a great pipe. Okay. That policy you should know, black, brown, all
Color
that
code, ma'am. Color code.
color coding. Based on that, you will know the values of the resistance. Okay. Okay. So whatever the practical resistance value when you get it, we'll have a tolerance of 5 to 10%. Hence, you can see here in the tabular column, they've also given you the a column to write what is the theoretical value and what is the practical value. Theoretical is whatever is been given to you already by us. That is all this value 6.8, 4.7, 3.3, 1.5 and 2.2 kilo ohms. Whereas this practical values is what you are going to measure using the color band. That is fine based on the tolerance. Because of this slight variation, say 0.03 some ohms, because of the differ in the resistance value, you can also see some difference in the current value with the practical and the theoretical values, whatever we calculate. Understood? Yes? Why
Yes,
the
ma'am.
voltage
Yes,
drop
ma'am.
is also given here, because voltage is given by defined by I into R, correct? So if I and R changes, obviously the voltage will also change. Hence, they have given you the tabular column for theoretical and the practical. This is what you have to fill it. So what we do is, before you come into any offline class, that is, you come to university to do any laboratory, all your lab observation should be in ready. Okay. There should be no left blank for any theoretical calculations which you have performed over the during our online classes. All of you understood that?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay. So there should be a blank of column only for the practical values where you can come and fill during our offline classes. Is that okay?
Okay, ma'am.
Okay. So what we are doing in this online laboratory classes, we will fill all the we will compute all the theoretical values and keep it ready. The manual will keep it ready. Okay. Once you come over here, just you need to plug in all the devices according to the circuit shown in the experimental setup, and then you can work on. Correct? Understood? So the resistors are required as per the circuit. We have 5 resistors. So 5 resistors of different values is there. That is what you will select to calculate the voltages and current. Okay. and breadboard is used to make the circuit ready. Okay, only one breadboard is enough, and you need a connecting wires in order to connect that multimeter to measure the current, or you can use even the ammeter. There is no problem, but it depends again if it is in milliampere or kiloampere. Depending on that, the rating ammeter, if you have, you can use it. Otherwise, it is better to have multimeter, very easy to measure the current values across each resistor. That is fine. Understood what I said?
Yes, ma'am.
Yes, ma'am.
Okay, these are the components used. Now let us analyze how to evaluate this circuit using KVL and KCL. Okay, let us solve this problem. Shall we solve this problem?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Can you all see this paint board, whatever I have here?
Yes, ma'am.
Yes, ma'am.
Yes. So what we do is, first we will do the calculation for the current. Okay. So first what we have to do, how many loops are there here? How many currents are flowing in each loop? There are two loops, correct?
Yes,
Yes,
Okay,
ma'am.
this is A loop and this is B loop. Isn't it? All of you are understanding what I am trying to tell?
Yes,
Yes,
ma'am.
ma'am.
Yes? Okay. So let us consider the node B and then we will look at the node D. Is it fine? Okay. Because there are only two junctions where all of them are meeting, correct? So we need to consider two nodes. Why we have to consider two nodes? Because there are two junctions where the components are being connected. Any doubts here?
No, ma'am.
Yes.
No,
So
ma'am.
let us consider the at. Right. Which of the current are coming in and going out of node B? I will identify one person and they have to answer me this question. Right. Rishabh Kumar is there?
Yes, ma'am.
Yes. Yes, Rishabh Kumar. Now you tell me at node A. Okay, one second. Yeah. At node B, okay, which are the currents entering and which are the currents leaving?
Ma'am, I1, I1 is entering and I2 and I3 is leaving.
So what we can have, I1, can I write like this? I1 is equal to I2 S I3. Can I write like this?
Yes, ma'am.
Correct? Sum of entering the node B is equal to sum of currents leaving the node B. So which are the node currents which are leaving the node B? That is I2 and I3. Correct?
Yes, ma'am.
Yes. So now we'll also write. Now you tell me whether I1 and I5 are same or different. Hello?
Yes, ma'am.
Current I1 and I5, are they same or are they different?
Different, ma'am.
Huh? Same.
Same.
It's same, ma'am.
Same.
Why?
Sorry, ma'am. Same. Yeah.
Why? Because they're flowing in the same loop A, correct?
Yes, ma'am.
The current I1 and I5 are same, correct? So what we have? All of you agree to this? Yes or no?
Yes, ma'am.
Now you tell me whether I3 and I4 are same or different.
Same.
Same, ma'am.
They are same, ma'am.
Right? They are the resistance R3 and R4 are connected in series, correct? Someone disturbance at some place, kindly mute it. Okay. Right. Now I1 is equal to I5 and I3 is equal to I4, isn't it?
Yes, ma'am.
Yes. Anyone is having any doubts in this?
No, ma'am.
No, ma'am.
No? Okay. Now let us consider the node D. Okay. And I will call Ronit Mohata. Is there?
Yes, ma'am.
Yes, Ronit. Can you tell me at node D what is the current equation?
At node D,
Yes.
I2 and I4 is coming, I5 is leaving.
Hmm?
I2 and I4 are coming, I5 is leaving.
So tell me the equation.
What do you do? I2 plus I4 equals to I5.
Yes. So I5 is equal to I5. Yeah. I5 equal to correct. Anyone having any doubts?
No, ma'am.
Okay. So this is basically what using what we wrote. This is using correct. Yes or no? Any doubts in this KCL?
No, ma'am.
Okay. Now let us calculate all the voltage drops first. Okay. Right. Let us calculate before we apply KVL. Let us calculate all the voltage drops. Okay. Now, what is the voltage drop V1? One. How do you write V1? Mohammed, you want to answer? Mohammed? Mohammed, Mohammed Saad, you want to answer? Shashank, yes, is there? Hello? Shashank, yes, is there? Hello? Hello?
Yes, ma'am.
Yes, ma'am.
Shashank, where is
Yes, ma'am.
Shashank? Can you raise your hand, Shashank? I'm not able to see you raising your hand. Okay. Now, can you tell me what is V1, Shashank? You're somewhere outside, is it? Hello? Are you somewhere outside, Shashank? Hello? Shashank, are you there? Hello? next class, I think it is better to take attendance and then give absentees for those who are not responding. Should I do that? Hello?
Yes, ma'am.
Is from next class, should I give absent for those students who are not responding?
Sure, ma'am.
So you cannot be just go offline and just making meeting in, correct? This is not done. Janu 2002 is there.
Yes, ma'am.
Yeah. Can you tell me now, Janu, what is V1? V1 from the circuit. Can you see here V1?
Yes, ma'am.
This is V1, okay? So can you tell me what is V1? How do you calculate from Ohm's law V1? What is Ohm's law?
V is equal to IR.
Yeah. So what is
Yeah.
the I is here?
Yes, ma'am. I1, R1.
1 and
R1.
R1. Correct?
Yes, ma'am.
All of you got this? Yes?
Ma'am.
Yes, ma'am.
Yes, ma'am.
Dhruti,
Yes, ma'am.
Yes, ma'am.
Dhruti is there? Dhruti is there?
Yes, ma'am.
So can you tell me similarly what is V2?
V2 equals I2 into R2.
2 and correct? Okay. Next, Karali Matti is there?
Yes, ma'am.
Yeah, can you tell me what is V3?
V3 is I3 into R3, ma'am.
Yes, I3 into R3, correct? Next, D Badri Raj.
Yes, ma'am.
Yeah, next, tell me what is V4?
I4, R4.
Next, Jashu Jashwant is there?
Yes, ma'am.
Can you tell me what is V5?
I5 into R5.
I5 into R5. Okay, so these are what? These are what?
Voltage drop.
Voltage drops.
Correct?
Yes, ma'am.
So now let us go in the loop A, B, D, E, A. Okay. So what loop we are going? Consider A, B, D, E, A. Okay. So we have to return to A. We have to start from A, return to A. Okay, start from A and then return to A. Now you should you know how to calculate the voltage drop, correct?
Yes, ma'am.
Right? Now you see that the loop how I am flowing is in the clockwise direction. Okay, two things you have to note. One is whether I am flowing in the clockwise direction and the current direction. If both are same, then you should give the voltage drop as negative. Okay, whenever you go from in the opposite direction, then you give the voltage drop as be positive. And also, whenever you go from positive to negative terminal, you give the voltage as negative. And whenever you go from negative to positive voltage, then you give the voltage as positive. Okay. So 3 rules you have to remember here. Which are the loop direction and the current direction. Same means voltage drop will be negative. Okay. If loop direction and current direction are not, then voltage drop will be positive. Okay. And direction of voltage from negative you go, it is plus direction of voltage from is minus V. Okay. Any doubts you have in this?
No, ma'am.
No, ma'am.
No, ma'am.
Okay. Now you consider the loop A, B, D, E, A. Okay. So in this, now I am going from where? A to B, positive to, I am going from positive to negative, correct? If I go from positive to negative, what is the voltage drop there? Minus
Negative
V1.
voltage.
Again, I am going from positive to negative V2, that is minus
V2
V2. And then I am going from again positive to negative V5. So it is negative.
minus V5
Minus V5.
Next, I am going from negative to positive with the
plus V plus V.
Any doubts here?
No, ma'am. No, ma'am.
So now you tell me, how do we write this equation? Vs is equal to what?
V1 plus
Plus
V2
V2 plus V5.
V. Correct? All of you agree to this?
Yes,
Now,
ma'am.
Yes, ma'am.
can I substitute V1 as I1 R1? Can I substitute?
Yes, ma'am.
R2 V5 as I5.
R5.
R5.
Any doubts here?
No, ma'am.
No, ma'am.
Right. But what is I5 from this node D? What do we have from here? I5 is nothing but what? I1, correct?
Yes, ma'am.
Yes. So what is Vs? Vs is equal to I1 R1
Plus R5.
Can I write like this?
Yes, ma'am.
Yes, ma'am.
Any doubts here?
Ma'am.
No, ma'am.
Huh? Any doubts here?
No, ma'am.
No, ma'am.
No.
No, ma'am.
No, ma'am.
Okay. Now, which loop I need to consider? Consider B, C. Okay. Now, someone else should tell me how do you get the voltage? Okay. Dhruti is there? Yes.
Yes, ma'am.
Yeah. So, can you apply the KVL?
Yes, ma'am.
BCDB.
Minus V3
Then.
minus V4
Yes.
plus V2
Yes.
is equals to 0.
All of you got this? Any doubts anyone is having?
No, ma'am. No doubt.
Ma'am.
Ma'am.
Oh. Yeah. Sorry. Anyone want to say something?
No, ma'am.
Okay. So now you tell me, how do I write this?
V2 equals to V4
No,
plus
no,
plus
let us
V4.
give right hand value as 0 only because we don't have any voltages applied here, correct? So let us keep it as 0 only. So can you substitute what is V3 now?
I3 R3.
I3 R minus what is V4?
I4 R4.
I4 R plus what is V2?
I2 R2.
I2 R2 0. Any doubts here?
No, ma'am.
No, ma'am.
Okay, good. What is I3 and I4? Are they same?
Yes,
Yes,
ma'am.
ma'am.
Correct? So I3 sorry, minus okay.
Minus I3 into R3 plus R4.
One second. I4 and I3 are same. Okay. I was thinking. Okay, we'll convert it. What do we have? Minus I3 of R3
R3 plus R4.
plus
I2 R2.
correct? Any doubts? Hello? Any
No,
doubts?
ma'am. No doubts.
No, ma'am. No doubts.
No.
Yeah. But can you compare 1 and 2? No, right? Can I compare 1 and 2 equation?
No, ma'am.
Because I have here I1 and here I have what? I3, correct?
Yes, ma'am.
So I need to replace this I3 with I1 minus I2, correct? From this equation.
Yes, ma'am.
From this equation, can I replace I3?
Yes, ma'am.
Yes, ma'am.
So what do you get? 0 minus. What is I3 now?
I1 minus I2.
I1 minus I2.
I2. Plus now the equation 1 and 3 are comparable.
Yes, ma'am.
Yes,
Only
ma'am.
thing is I need
Yes,
to
ma'am.
subtract I1 and I2, correct? K2K is there?
Yes, ma'am.
So can you separate I1 and I2 and tell me what is the final equation?
Ma'am, for the second equation, third equation, no?
Yes. You're somewhere outside, is it?
Yes, ma'am. Actually, I'm outside. That's right.
You should not go, no, during the class hours.
No, ma'am. It was actually a government for the Aadhaar card, and that's why I have to come to the bank. That's right.
But you have to intimate the teacher or faculty or whatever it is. You cannot just be like this, correct?
Okay, ma'am. Next time I'll make sure.
Yeah. Otherwise, it will not be taken as simple as this. Okay.
Okay, ma'am.
Yeah. So now you tell me, how do you differentiate I1 and I2 and separate and tell me. Hello.
Yes, ma'am.
I'll ask someone else. It's okay. Lakshmi is there? Lakshmi Narayan Reddy is there? Lakshmi? Lakshmi? You're not online, Lakshmi? Hello? This is not done. One student, okay, two student, okay. Many are doing like this. Going somewhere else. Kushal Srinivas is there. Kushal is there. Hello. Ayush Ranjan is there.
Yes, ma'am.
Yes,
Yes,
kindly
ma'am.
answer this. Next time I'm going to note it down who are all doing this, okay, right?
Ma'am, can I answer it?
Yeah, please. Tell me the
Yes, ma'am. Minus I1 R3 minus I1 R4 plus I2 R3 plus I2 R4 plus I2 R2.
no. Can you tell me overall equation?
Yes, ma'am.
Final.
Just a minute, please. Just a minute, please, ma'am. Ma'am, hello. Am I audible, ma'am?
Yes, yes.
Minus I1 into R3 plus R4 plus I2 into R3 plus R4 plus R2.
Is it correct?
Yes, ma'am. Yes, ma'am. Plus
Yes.
I2
Yes, ma'am.
into R3 plus R4 plus R2.
Plus it is there.
Yes, ma'am. R2
Minus.
plus R3 plus R. Ma'am, ma'am, you have to
Okay.
put a plus after R2. Yes, ma'am.
Okay. Minus into minus plus. Okay.
Plus R3 plus R4.
How many of you got this correct? And how many of you didn't get it? All of you got this?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
I have got the same.
Okay. So next, what you have to do is substitute all the values of R1, R2, R3, R4, R5 and Bs into this 1 and 4 equation. Okay. And tell me the equation, what do you get? Konda Pannin Rajeshwari is there?
Ma'am, yes, ma'am.
Yeah. Now substitute the values and tell me the equation 1. Substitute values in equation 1 and tell me. You're also outside, is it?
No, ma'am.
I can hear some voices.
Ma'am, that is fans on, ma'am.
Yeah, tell me now. What do you get? Substituting the values in equation 1.
Ma'am, once show please R1 and R5 values and I can't see. R1 and R2, R3, R4 values I cannot see, ma'am. Ma'am, first equation is I1 into 9k plus I2 into 4.7k equal to 10, ma'am.
I1 into?
I1 into 9k.
1 second. 10 note, correct. I1 into?
9k.
9k. 9k, okay.
Plus I2 into 4.7k.
Hmm. I2 into?
Ma'am, I2 into 4.7k, ma'am.
All of you have got the same or different? Hello.
The same value.
Yes, ma'am.
Same, ma'am. Yes, ma'am.
Same answer.
Now you tell me the second, substitute all the values in equation 4 and tell me what you get.
Ma'am, what should the values, ma'am?
You have to write down. All of you, I hope all of you are writing in your observation books.
Yes, ma'am.
Yeah, ma'am.
Ma'am, I just one question. Last class, you actually had asked us to write in the manual. It looks different with when compared to the one that you are showing in the manual.
And that is last session we discussed is verification of Ohm's law, no?
Okay, because
Yes, ma'am.
last class you just asked us to write. We didn't do anything in that. This is the first lab where we're actually doing something.
Verification of Ohm's law, you did it in software, correct?
Yes,
And I
ma'am. So
might,
that's it. That was the only one.
yeah, that is the only one you have to write it.
Okay, ma'am.
Ma'am, fourth equation
Ma'am,
is
those tabular column we need to fill, ma'am.
Yes,
For
yes.
okay, ma'am.
This one we have to write same how it is. Everything we need to write it in the manual as well.
Yes.
Okay.
ma'am, fourth equation is minus I1 into 4.8 into 10 power 3 plus I2 into 9.5 into 10 power 3.
How will I write it if you go like that?
Minus I1 into
Uh,
4.8 into 10 power 3 plus I2 into 9.5 into 10 power 3.
How many of you didn't get this and how many of you got it?
Got it.
Hmm?
Yes, ma'am. Got it.
All of you have got it?
Yes, ma'am.
Yes. And all of you are having the calculator with you?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Scientific calculator do you have?
Yes, ma'am.
Yes, ma'am.
Okay, do you know how to use it? Have you used it
Yes,
in your
ma'am.
class?
Yes, ma'am.
Yes. So go to equation and solve for I1 and I2 currents.
Ma'am, I1 is 0.87 amps.
1 second. One minute. So what is I1?
0.879 amps.
Milliamps, correct?
Yes, ma'am. Yes, ma'am.
Yes. One is
0.879
milli
amps.
amperes.
I2
Got
is
this?
0.44 milliamps.
milliamps.
Yes.
Ma'am, for this after decimal point, we have to take 2 values or 3 values, ma'am, in labs.
Two values you can take, no problem.
Okay.
Right, all of you got this?
Yes, ma'am.
Yes.
Yes.
Yes, ma'am.
Yes, ma'am.
Now you from this is whatever we did using what we calculated. This is the KVL, correct? Isn't it?
Yes, ma'am.
Now what you have to do is, you know from KCL the currents values, and you know now you have calculated what is I1 and I2. Can you calculate I3, I4 and I5 from this KCL equations?
Yes, ma'am.
Yes, ma'am.
Yes,
I2,
ma'am.
Yes, ma'am.
I3, I4, I5, all the three currents you calculate and check whether I1 you get it same as whatever you have got here after substituting there. Okay, right?
Okay, ma'am.
Tell me, what did you get I3 as? What is I3?
0.4
I1 minus I2.
0.439.
0.43.
0.43 milliampere or normal?
Milliampere.
You have to specify the unit properly, okay?
Okay, ma'am.
What is I4?
0.43
same as?
milliampere.
Yeah. What is I5?
0.87
Same as I1.
milliampere.
How much?
0.87 milliampere, same as I1.
Point
87
7.
milliampere.
Okay. Now I1 we have I3 to verify whether we get. Obviously we will get it. So how much do you get? I2 plus.
0.87 milliampere.
If you got this?
Yes, ma'am.
Yes, ma'am.
So can you see that? These two values are same, I1 and here and there.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
The next is we have to do verification of KVL. Okay, so verification of KVL is just you have to add V1 plus V2 plus V5. We have to find all the voltage drop, V1, V2, all this. Okay, and verify this equation, right? So Now anyone tell me what is V1 and I1 into R1, you tell me. How much do you get? How much do you get? I1 into R1? 0.887 milliampere into R1. How much do you get?
5.91
Huh?
5.91
5.91
millivolts V. Okay.
R1 is kilo ohms, no? So do you get millivolts?
Ma'am, no volts.
Will that not cancel? Milli
We
and
get
K?
volts.
Kilo.
Huh?
We get volts.
You get just volt, no?
Yes.
Okay.
How only volt? You tell me 10 power minus 3 into 10 power 3. So how do you write? 10 power minus 3 plus 3. What do you get? 10 power 0. 10 power 0 is 1. Correct? Understood?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So next, what is V2 or I2 R2?
2.068 volts.
Next, what is V3? What is V3 I3 into R3? Do it.
1.41 volt.
Yeah.
1.41 volts.
What is V4?
Zero
0.64 volts.
volts.
What is V5? I5 into R5, do it.
1.9.
1.91 volts.
Okay. Now what do we have from the equation 1? Let us take this equation. Substitute all the values of I1, R1, R5, I2, R2, everything in this equation 1. What do you get? The answer as
9.88 volts. V1 plus V2 plus V5.
how much do you get?
9.88.
So that is around 10 volts. Right?
Yes, ma'am.
Hence, can you see that voltage and current, both of them are being verified?
Yes, ma'am.
Yes, ma'am.
Okay. So how to write in your manual, I have explained. Once again, my co-faculty, Miss Nikita, will explain you that. Nikita? Nikita? 1 second. Hello.
Yes, ma'am.
So anyone else having any doubts in solving this experiment? Hello.
No, ma'am.
No, ma'am, no doubts.
Ma'am, this experiment we have to write in the Word document or in our practical
Word,
notebooks.
Word document, and
Okay.
in your observation book, all the calculations should be there because it carries marks,
Okay, ma'am.
right? So I don't allow any student to come during your offline class without your observation books.
Okay, ma'am. So the manual we need to fill in the details, and that we need to write in a separate book, or only that is only for the Word document.
Word document, you have to print the sheet.
Sorry, ma'am,
To
I
write
couldn't
your,
hear you.
you have to print the sheets.
Okay.
To write your Word document, create one manual, one file.
Okay.
Okay, my colleague will explain you in short moment how to do it.
Okay. And all of this should be in a separate observation book.
Yes, yes,
Okay.
absolutely. Each day experiment, you should write date on each day. Whenever we take class, the date and your writings should be there.
Okay, ma'am.
Okay. Yeah. So my colleague will tell you how to write the observation book or even the manual. Yeah.
Hello everyone. Guys, are you able to listen to me?
Good
Yes,
afternoon,
ma'am.
ma'am.
Good
Yes,
afternoon,
Good
ma'am.
ma'am.
afternoon.
Good
Good evening,
afternoon,
ma'am.
ma'am.
Good afternoon,
Yes,
ma'am.
ma'am.
Good afternoon.
Good afternoon, ma'am.
The manual. Uh, Guys, right now we have solved the problem, right? KVL, KCL.
Yes, ma'am.
And you have already seen the printed manual.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Ma'am, everything they have to fill in printed manual. Instead of writing in observation, what I want you to do is write introduction. No need of introduction actually. Heading, aim and objectives. Hello. Hello.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Aim and objectives. Then components required. Circuit diagram is necessary, and you have to solve the problem. Once you solve the problem, then you can fill in this tablet columns. No need to write this procedure and precaution right now in your observation. It will be in your manual itself. Then you have to fill in the tables, all the two tables which you see, right? Both the tables you have to fill, and you have to write the analysis and discussion, then conclusion. Analysis and discussion you can write in manual itself. Here only conclusion. In observation you have to write analysis and discussion, then conclusion. Okay, guys.
Okay,
Ma'am,
ma'am.
what do we need to write in analysis and conclusions?
Analysis and conclusion, you have to write why you have got the same answer. Justification of the resistance and everything. Please do not write this analysis and discussion in your manual. Okay, this you write only in your observation. When you
Okay.
are doing, no, let them not write in manual, because in manual what we'll do is, when you see practically resistance of each resistance and when you measure it on breadboard, right, you'll get a difference. You have to write why you will see such differences. Here in analysis and discussion, you have to just give justification. In observation, you just give the justification because you have not done the practical, right?
Yes, ma'am.
Just write what is disadvantages of KCL and what is advantages of KCL. For which kind of circuits you cannot apply KCL and KVL. You can write that. Okay. And
Okay.
discussion, whatever you feel about this problem, right? You can write within 2 or 3 lines. That is
Take
enough.
some values and then write on it.
Exactly.
And ma'am, what to
Then
write in conclusion?
in which one?
Conclusion.
Conclusion.
Conclude that by using KVL, KCL, I have found out all the branch resistances and voltages. You have to write down those things. Conclusion should be only two lines. Okay. I have computed voltage. See, if you are read your aim and objective, right? What is your aim? To compute voltage and current for each parameters in the circuit. That you should conclude that you have calculated it using KVL and KCL. That's all.
Okay, ma'am.
And verification is also done using KVL and KCL. Is it fine?
Yes, ma'am. Ma'am, and in the manual, we just need to fill in the table with the theoretical values.
Table with theoretical values. Once you come here, you can write analysis and discussion over here differently. In observation, you just write this, okay, whatever
Okay,
you
ma'am.
observe. Okay, but don't write analysis and discussion in your manual.
They tell them all the tables
You can
should
come
be
here and you can
completed.
type. And all the tables you have to write every values. Theoretical you can write, practical you have not done, right? You can leave it empty.
Okay, ma'am.
V1
Okay,
you
ma'am.
might have calculated, you got some value. V2 you have got. Similarly, practical, since you have not done, you will do it after coming here. Leave only that column empty, okay?
Okay, ma'am.
Okay, ma'am.
This table, data number 7, data collection and tabulation, you have to fill in all the values. But
Yes,
table
ma'am.
number 9, what you see, only theoretical value if you fill, it is fine.
Okay, ma'am. Ma'am, and should we write calculation in the manual as well?
What you have to do for manual is take printout of this same book, okay, what we have sent you. After each experiment, you have to add 2 A4 sheets. That is for calculations.
Okay, ma'am.
Are you able to listen to me? Whatever
Yes,
calculation, we have not left space over here, no? So
yes, ma'am.
after that, you have to spiral bind everything everything. Okay.
Okay, ma'am.
And above and below, one transparent or OPH sheets you will get, right? Transparent
Yes,
sheets.
ma'am.
Plastic. So you have to even add that and you have to submit to us.
Okay, ma'am.
Is it fine? So now what
Yes.
you have to do? In your observation, you have to write aim and then components required, then circuit diagram. Later, no need to write procedures or precaution. Directly write 2 tabular columns. In that you fill all the theoretical values, everything. Okay. Analysis and discussion, write in three lines. Analysis is 2 lines. Discussion can be 2 lines. So later conclusion. What will you conclude? What is the aim that you have given? To verify, to compute voltage and current for each parameters. So your conclusion should be, I have come that you have to write in the sentence. I'm just telling casually, but you have to make it a neat sentence, okay? That I
Yes,
have
ma'am.
calculated voltage and current for each branch using KVL, KCL and Ohm's law. Then second point, I have also verified the Kirchhoff law and Kirchhoff both the laws, okay? This should be your conclusion and then you have to end it. Is it fine?
Okay, ma'am.
Okay, ma'am.
How will you bind your this manual?
Spiral bind.
Spiral bind.
Spiral
Then
binding.
yeah, after each experiment, you have to keep 1 or 2 A4 size sheets, empty sheets, okay? Then spiral
Okay.
bind. On the above and below, you have to put the plastic sheets.
Transparent sheet.
OPH, transparent. It's fine if it is transparent, it is better. Okay.
Okay, ma'am.
Any doubts?
No, ma'am.
Okay. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
So all of you understood how to write your observation and the manual, correct?
Yes, ma'am.
Yes, ma'am.
With this, we'll be ending your session for today, and I hope from the next class I don't want any out of the class and then attend the class.
Okay, ma'am.
And I'll make a note of that student, and that will be recorded for in future to make an attendance AB. That is absent.
Okay, ma'am.
Okay, ma'am.
This
Yes, ma'am.
Okay, ma'am.
should attend the attendance for this class, right? Else you will not be able to concentrate what is being done, right? And you know that 80 to 85% of attendance is compulsory, without which you will not be able to attend your main exams, correct?
Yes, ma'am.
Yeah. So thank you, enjoy your the day. Yeah.
Thank you, ma'am.
Thank you, ma'am.
Thank you,
Jai
ma'am.
Shri Ram.
Thank you,
Jai Shri
ma'am.
Ram. Jai Shri Ram.
Enjoy your day, ma'am.